So it says let A is equal to a matrix which is having element x plus 1 greatest integer, x plus 2 greatest integer, x plus 3 greatest integer, and x greatest integer, x plus 3 greatest integer, x plus 3 again greatest integer, and then x greatest integer, then greatest integer of x plus 2, then greatest integer of x plus 4. So this is the matrix, and this box we are using to denote greatest integer function. Okay. Now they are saying that the determinant of A is equal to 192, then x belongs to what interval? So first try, then we will discuss it. One basic thing which we need to know about greatest integer property here is that greatest integer of x plus n is actually greatest integer of x plus n if n belongs to any integer. So n can be taken outside. So this is the hint to do this question. So when we will apply this property, what you will get actually is that A is equal to, and this is 1 second. This becomes greatest integer of x plus 1, x plus 2, x plus 3 like this. And in the second row, x plus 3, x plus 3. And the third row, x plus 2, x plus 4. So this is what you will get A as. Now you can do some row operation and column operation. and then it will be easy to find determinant of A. So there are many ways in which you can do row and column operation. So basically here, let us suppose we take R1 as R1 minus R2 and R2 as R2 minus R3. So this A matrix becomes R1 minus R2 will be 1. This will be minus 1. This will be 0. And R2 minus R3 will be 0, 1, minus 1. And this is greatest integer of x. This is greatest integer of x plus 2. This is greatest integer of x plus 4. So we get this. Now we can calculate. We can expand about the first row. So 1 and greatest integer of x plus 4 plus greatest integer of x plus 2 it will become. Then minus 1 it will be plus 1 as it is first row second column, and it will be greatest integer of x you will get, and x will be 0. Okay. So greatest integer of x plus greatest integer of x plus greatest integer of x is 3 times of greatest integer of x plus 6 it will be. Now it is given that this is equal to 192. Now we know that 3 greatest integer of x plus 6 is equal to 192, which means 3 greatest integer of x is equal to 186, which means greatest integer of x will be 62, which means x belongs to 62 comma 63. Then only greatest integer of x will be 62. So this will be your answer. X belonging to 62 comma 63 interval, where 62 is included, 63 is not included. Let me write it clearly. So you can write it down, this operation we did, then we found this result. You can write it down. So let us come to the next question. So next question is, let a comma 0 comma b comma 2b plus 1 and c 0 comma b is not equal to 0 and mod b is not equal to 1, be points such that be points such that area of triangle ABC is 1 square unit. Then the sum of all possible values of A is, options are given, minus 2b, 1 second. So we have minus 2b by b plus 1. Second option is 2b by b plus 1. Third option is 2b square by b plus 1. Fourth option is minus 2b square by b plus 1. So try this question. So you know the formula for area of triangle ABC if the vertices are known to us. What is that formula? That formula we study now, that area is equal to the half of mod of
Yeah,
determinant of,
X1,
yeah,
Y1,
x1 y1.
1.
Correct, correct. So A01 B2B plus 1 1 and
Mm.
0 B1.
Yes, sir.
This is what we are getting.
Yes, sir.
And area you have to calculate and equate it to 1 square unit. So you can
Yes, sir.
simplify this. What you are getting after simplification?
Sir, I'm still doing it.
So your voice is little low. Let me write it here. So this will be mod of A into 2B plus 1 minus B. And then next is 0. And then next is 1 into B square mod of this. So this will be half A into B plus 1 plus B square. So it is AB plus A plus B square mod by 2. And they are saying that this value is equal to 1 square unit. This is equal to 1. So 2 will multiply there and this will become 2. Okay. So from here, we are getting A into B plus 1 plus B square is equal to plus minus 2. When we will remove mod, we get plus minus both. So A is equal to plus minus 2 minus B square by B plus 1. So this is plus minus 2 minus B square by B plus 1. These are the two values of A. One is plus 2, another is minus 2. So when we will add them, so sum of A is equal to plus 2 and minus 2 will cancel and it will be minus 2B square by B plus 1. So your answer will be option D. Sorry. So you can write this. So let us come to the next question. I hope you have written it. The question says the number of one second. So the number of distinct real roots of the determinant is given sin x, cos x, cos x, then cos x, sin x, cos x, then cos x, cos x, sin x is equal to 0. X is given between minus pi by 4 to plus pi by 4. Yes. And options are 4, 1, 2, 3. 4, 1, 2, 3. I'm giving you 2 minutes, then we'll discuss. Are you trying or should I discuss?
Sir, can you discuss?
Okay. So what we can do, we can simply apply the expansion of determinant here, or mm, we can do one more thing. Let us add row 1 as row 1 plus row 2 plus row 3. So what we will get is sin x plus 2 cos x, and here also sin x plus 2 cos x, and here also sin x plus 2 cos x. And then there is cos x, sin x, cos x. And then we have cos x, cos x, sin x. So sin x plus 2 cos x can be taken common. And we have 1, 1, 1, cos x, sin x, cos x, cos x, cos x, sin x equal to 0. Now it will be sin x plus 2 cos x. And when we will expand the determinant, it will be sin square x minus cos square x, then minus cos x sin x minus cos square x, and then plus cos square x minus cos x sin x. This is what we are getting. And this is equal to 0. So sin x plus 2 cos x is there. And what we are getting is sin square x, and there will be plus cos square x, which will be 1. So what we do here is, we take this sin square x and this minus minus plus cos square x, which will become 1. And then we can cancel this minus cos square x and plus cos square x. What else we are getting is minus cos x sin x and minus cos x sin x minus 2 sin x cos x, which is sin 2x identity, is equal to 0. So we are getting this. From here, either this is 0, which means sin x is equal to minus 2 cos x, or sin 2x is equal to 1. So what we can say is tan x is equal to minus 2, or sin 2x is equal to 1. Now the angle is given between pi by 4 and minus pi by 4. So minus 2 is a value for which x will be less than minus pi by 4. Because if you remember the graph of tan, it is like this. So at minus pi by 4, it is minus 1. At pi by 4, it is 1. That is 45 degree. So from here, between minus pi by 4 to pi by 4, you will get no solution. And here sin 2x is equal to 1, means 2x is equal to pi by 2. So x is equal to pi by 4. So one solution will be there, which includes pi by 4. So its answer will be 1. Yeah. So 1 is given as its answer, option B. You can write it down. First you write till here, then I will scroll down. I'm scrolling it down.
Oh, okay, sir.
Okay. So let us come to the next question. This is also a little bit of trigonometry is involved here. The solutions of the equation one plus sine square x, sine square x, sine square x, and cos square x, and 1 plus cos square x, and cos square x. And here it is 4 sine 2x, and then 4 sine 2x again, and 1 plus 4 sine 2x is equal to 0. And it is given that x is between 0 to pi. Our options are given to us: pi by 12 comma pi by 6. Option B is pi by 6 comma 5 pi by 6. Option C is 5 pi by 12 comma 7 pi by 12. Option D is 7 pi by 12 comma 11 pi by 12. Just give it a try first. So should we discuss or you have got the answer?
No, sir.
Okay, so let us discuss. So what you can do first is do row operation. So since it is given like this, so what we do, we take first row 1 plus row 2. So row 1 is row 1 plus row 2. And in that case, it will be 1 plus sine square x plus cos square x, which will be sine square x plus cos square x is 1. So 1 plus 1 is 2. Here sine square x plus 1 plus cos square x is again 1 plus 1, 2. Then sine square x plus cos square x will be 1. Here it is cos square x, 1 plus cos square x. And then cos square x. And in the third row, 4 sine 2x, 4 sine 2x, and 1 plus 4 sine 2x. And this is equal to 0. Now, next thing what we can do is, we can take column 1 as column 1 minus column 2. So it will be 0, it will be minus 1, and this will be also 0. And it is 2, 1, 1 plus cos square x. And one more thing we can do. We can also apply column 2 minus column 3. So C1 as C1 minus C2 and C2 as C2 minus C3. So it will be 1, it will be 1, and it will be minus 1. And it is 1 plus 4 sine 2x is equal to 0. Now, we can say if we expand about the first column, so 0 and 1 plus 4 sine 2x plus cos square x it will be, but it is 0. So no need to write this. 0 is multiplied with it, na? So it is 0. Next is minus 1. So it will become minus minus plus 1. And first column and second row, let us eliminate. So it will be 1 plus 4 sine 2x plus 1. And another term is again 0. So this is 2 plus 4 sine 2x is equal to 0, which means 2 common. 1 plus 2 sine 2x is equal to 0, which means sine 2x is equal to minus 1 by 2. So this is sine 2x, which is minus 1 by 2. Now, x is between 0 to pi, as it is mentioned here. X is between 0 to pi. X is positive. Sine 2x could be minus half in the third and fourth quadrant. First and second quadrant, it is positive. It is negative in third and fourth quadrant. So 2x is equal to pi plus pi by 6. That is the third quadrant, or 2 pi minus pi by 6, that is the fourth quadrant. So it will be 7 pi by 6 or 11 pi by 6. This is 2x. So x will be equal to 7 pi by 12 or 11 pi by 12. So these two answers are coming, 7 pi by 12 or 11 pi by 12, which is option D. So please write it down. Then I will scroll it down. So I'm scrolling it down.